Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are working on model 3, that too on development of surfaces. We have discussed briefly the sections of solids along with basics of development in the previous session. This session we will take two problems which are very important to know to go for further discussions on developments. Now let me take a problem. A square prism of 40 mm base edges and 60 mm height has its base on HP such that one of the base edges parallel to VP. It can be perpendicular to VP also. It is cut by a section plane inclined at 45° to HP and passing through the top right extreme edge or top right edge also okay. Draw the development of lateral surface of the remaining portion of the solid. Now I will tell you what are the methods of development and suitability of the development of surfaces. One is parallel line method. Parallel line method which suits the prisms and cylinders. And the second one is arc method, that is for the cone and the pyramids. Here we have square prism as a basic problem and we will work out that. Now here, as per the information, I have taken one of the base edge parallel to VP. In this case, square, we have two base edges parallel to each other. Definitely one is parallel to VP, other one is also parallel to VP. Otherwise, you may give one of the base edges is perpendicular to VP. See, AD is perpendicular to VP. At the same time, BC is also perpendicular to VP. So any of the conditions works out. So since it's a basic situation, that is position of the solid, standard position of the solid. Now you know how to draw the projection of the solid. To start with, you draw light lines. All lines adjust must be light lines as per the construction line only. Now naming, as usual, you must be very careful in naming in case of development. In other cases it works out, you can do somehow or the other, you can come to the final answer. But here it leads to the mistakes. So you must have the extreme right edge as the starting point, A, B, C, D, then project it and get the respective front view. Now dimensioning, as usual, you work out the value is 40, height is 60. Okay, naming and all AA1, BB1, CC1, DT1, fine. These are all the vertical edges. Now I will take up the model simply with a reference given. The base edge is parallel to VP or base edge perpendicular, it is parallel to VP. Now I am very particular about vertical edges, AA1, BB1, CC1, DD1, top face base. Okay, A1, B1, C1, D1, ABCD. That's what I have identified. Next, how to draw the development of this? Let us forget about the section plane and all. Overall development of the solid only we have to draw for all problems. So first, how to draw the overall development of the entire lateral surface. Forget about the base and top face. Development means here it is only lateral surface. Okay, now parallel line method. Now let me restrict XY only to this part. Then from this onwards, development part. Now draw parallel to the base and top face lines. Okay. Next, start with a initial edge. Initial edge must be always this one, AA1. Start with this extreme right edge, AA1, BB1, CC1, DD1. Let me start from AA1. Name this as AA1. Capital letters, small size, not small letters. Next, take the base distance, draw arcs. 4 arcs you draw, equal distances. Then draw vertical lines. All are thin lines. Now name B1, C1, D1. Again A1 will come. Once you close it, now I have a simple model of development. Assume that already developed, and then I try to join and get. Okay. So this is A1, B1, C1, D1, A, B, C, D. Now I open this and then stretch. See, A, B, C, D with suffix 1. A1, B1, C1, D1, A1. Again, A, B, C, D, A you will get. So, name this as A, B, C, D, A. All are light lines. Why? Because the involvement of section plane is there. If that is nothing is there, just the development of the lattice surface of the complete prism, you have to dark all the lines. That's all. This is how you draw the development of the lateral surface of the square prism manually. In case of computer, you select one line and choose offset. I will explain in the computer how to do it. Okay. Now, naming A, B, C, D, A1, B1, C1, D1, A1. Now, dimensioning must be very clear. 40. Then overall development length, capital L. Normally we use it. This is 160. That's all. Next, how to fix the section plane? According to the requirement, we have to draw 45 degree through this point. This is right extreme point, top point. If it is left extreme, you have to choose this. Now draw 45 degree line through that. The convention for section plane is full line hyphen, full line hyphen. Okay, like this you have to draw. At the end, you make it little dark. Let it go out of solid. That is the convention. Then draw perpendicular line and keep arrow. That means you are expected to retain the portion below the arrow. This starting from this, you have to cover this up to this one. So this portion is to be removed and this is to be retained. Now I have simple model of having the bisecting the axis here. Okay, now assume that this is the section plane and the top one is taken out. Okay, so this is what the section you get. Okay, see this is 1, 2, 3, 4. Now I will write how to keep 1, 2, 3, 4 here. That is intersection points with the edges, longer edges. This is 1 dash intersection of section plane with the longer edge A1, vertical edge A1 is 1. And suppose that the section plane is here. Section plane is here, then you would have marked here 2. Here it is exactly coinciding with the top corner of the BB1. This is 2 dash. Again, top corner of CC1 is C dash only. That is 3 dash. 1 dash, 2 dash, 3 dash, 4 dash. Here actually 1, 2, 3, 4. Okay. Now 4 dash. Okay. The other portion, the top portion, if the things are given like bisecting the axis, not the top corner, then the top portion will also to be removed. Now, what are the portions to be darkened here? Check this twice and mark. This is very important. Better you first mark dark lines and then name. Okay. Now, after naming this, see here, we already completed the overall development thin lines. Now, identified the intersection of longer edge with the section plane. Now, start projecting these points towards development. So, now 2 and 3 are key points here. It's exactly coinciding with B and C. This is 2, this is 3. No need to project. Only one line you have to project, that is 4 and 1. Completely you project because you get 1 here, that is on AA1. Again 4 on DD1. Next comes here 1 again. Don't put any prime or dash because this is the actual thing. Development is on a flat surface, true lengths. Okay. Now in sequence I have 1, 2, 3, 4, again 1. 1, 2, 3, 4, 1. Each and every point is very important. Next, dark all the points. Profile is this. The section you have and the corresponding portion, particular portion is removed and then retained a remaining portion development we are working, and this is what the dark lines you have to complete. This is the pattern. Now remaining portion 1 to A1, 2 to B1, all are retained, 3 to C1 is retained, 4 to D1 is retained, 1 to A1 is retained, and also the boundary, complete base edges are retained. The dark line means you have retained the portion. This is the cut portion is actually referred to section plane profile, that's all. Now this is what the answer is. This is the solution, and normally we forget to dark these two and also this one, 3. So assuming that that is the answer. Actually these are actual edges retained, and this is the portion of the edge is retained. This is the complete two edges are untouched by the section plane. It is touched, but it is just crossing the, that's what he says, it is just passing through the extreme right edge. So this is the solution of the square prism with section plane inclined at some degree THP and passing through the right extreme edge. Now let me take one more interesting and simple solid, the square solid. Now before that I will show you the development which I got and remove the top portion. Okay, so this is how you will get, and the portion which is removed is this. If the portion is obtained with the bisecting the axis, not passing through this. Okay, so otherwise if you assume that this is the height, then this is the retained portion, and this portion is, again I can say this portion, only this portion you can say, and then this is the portion to be removed. So this is about the first problem. Next, the solid is interesting and simple solid, square pyramid. It has got same base shape, that is square, with one side perpendicular to VP. I have given, just for change I have given. I would have given parallel to VP only. One side parallel to VP or one side perpendicular to VP. Here it is two sides parallel, two sides perpendicular. Now in this case, the section plane is bisecting the axis and inclined at 45 degree. It may leaning downwards left, or it may lean the right downwards. Okay, both are okay. Unless it is mentioned by default, you can take normally the if you go for section of solids, we used to have true shape here, this side, okay, because space is available, forward direction. You used to take this. So now let me mark a point. You know how to draw the top and front views in this position. That is, again, the dimensioning and all you have to do as usual. Yes. Now you have to keep everything light or light lines. Now take the section plane. Draw section plane with 45 degree inclination. Now select this midpoint. This is 30 mm. This is the point, you can say. Now draw 45 degree line. So if you draw 45 degree line, you select fix any means, then draw it. So again, full line hyphen, that is the convention for the section plane, and at the end dark little bit and then put arrows. Okay, then dark first, before naming the intersection points, you dark the portion which is retained after taking section. Yes, this is the front view. You concentrate only on front view. Don't worry about the top view. No need to dark. Whatever the light lines are there, leave it. In case of section of solids, we try to project there and then mark all points and show it, because that is necessary there. Here it's not necessary. Only keep naming proper, intact, and then dimensioning, etc. Otherwise, you need not worry. If there is any need, then only you have to touch top view. Now you have to do it because top view is very important. Now you need not have to draw, but procedure and all you have to do properly. Now let me start working this particular problem. Before that, let me keep naming of intersection of points. This is 1 dash of intersection of section plane with VA. VA is intersecting the section plane at 1 dash. Again here at 2. VB at 2. VC at 3 and this at 4. Now I will show you in the model how exactly this happens. So this is the development you have and this is the model I have prepared for that. Now I have this, assume that I made a section and then with inclination etc. This becomes 1, this is 2, this is 3, this is 4. This is ABCD. ABCD, this is VA intersecting at 1, VB at 2, VC at 3, VD at 4. This is what? 1, 2, 3, 4. If you keep it like this, you can see only 1 and 2, not 3 and 4. Okay. So I have made the intersection points fixed. Then you need not fix that on top view, not necessary. Okay. Only thing is you have to get the development with the arc method, radial method, that is referred to as radial method. In fact, now before that I must know the true length. Say whatever is available here in this development pattern, all are true lengths. Even in this case, this is the development of the square prism, all are true lengths. If I keep it on the flat surface, these base edges are true lengths, slant edges are true lengths. How to get this? What are these actually? These are true lengths, slant edges, true lengths. How to get this true length of slant edge? Is it available here? Yes or no? No, I say no because VA, VB, VC, VD all are inclined to XY line. At the same time, in front view also it is inclined. None of the lines are parallel to XY line. When you get true length, this is XY, this is a line inclined to HP. At the same time, this is inclined to VP. So let me take case of VA only. All are like that only. VA, V dash, A dash. So none of the lines are true length. What do you do for that? How to get the true length in case of straight line? We used to make it parallel. Used to make it V, A1 I can say. Then project onto the locus of A dash and get A1 dash. Generally, this is the procedure you have to follow. Make it parallel and project to get the true length. Okay, so that is what I am going to do here. Very clear from this particular problem. Suppose that I keep like this, make all lines, all base side just equally inclined to VP, then you will get the top view, front view like this. This is top view and corresponding front view is this. Yes, this is V dash, this is V, this is A, B, C, D. A dash, B dash, C dash, D dash. Now let us check the true length is available or not. See, this particular line and this line, either side, this is A, B, C, D, V, C, V, A. Both are parallel to XY. Definitely the corresponding front views are true length. That is what I did. I made it parallel and then projected onto the locus of the moving end. That moving end is A, fixed end is V here. I get true length. So same thing we have to follow here. What I have to do is, here VS center, I am calling V, not O. Actually, that is VB. VB is the reference for me. VBS center, VBS radius, VS center in this figure, draw an arc. That means we are making parallel to XY. VD, this is B1, B2 or B1 you can say. This is B1 because I am anticipating B1 dash there. Any name you can give. You can give BM, then BM dash. That's all. So next comes project it and get here on the locus of B dash, we get B1 dash. That's what this convention we use in straight line problems. Now, very important line in this problem to process this green line. That is V dash B1 dash is true length of slant edge. That we have to take now for consideration of radial line method. First you have to take that as radius and draw an arc and then start working. How to do it? So you can start wherever space is available. Suppose this space is available for us, then you can draw a line at any angle, but available space is less for me in this case only. What I do is I can draw a line like this. I can use V as this because I can use arc like this. Suppose I have this way horizontally, then I can draw. It's like a pendulum, keep moving either side. So now start taking V as reference and then take this true length. This is true length. This is very important length for me. Take true length equal to radius. True length VB1 equal V dash V1 dash equal to radius. Draw an arc, very big arc, so that you have to cover both sides there. VB is the thing. Now let me name the starting point is VA for me always. Whether you take, even if you take VA and do it, same distance you get, all are same. Now because when I write regular pyramids and prisms and also the cone and cylinders, these are common characteristic feature, all are same, generators and the slant edges. Now what I do is I start from VA. Then I have to cover VA, VAB, VBC, etc. You need not do individually. Take this equal to radius with compass manually and draw arcs. In computer, you fix one triangle VAB and then start keeping mirror. Okay, you will get all the lines. There are many other techniques. Here, mirror we can use and do it. Okay, now join these lines, very light lines, 1, 2, 3, 4, fine. Now I name this as B, this is C, D, A. Now you can ask me why you took in this way vertically. Now I can take like this also. If a space is available, you can start VA and draw line, keep this way. No problem. Any type you can take. Since I have space like that, I have taken. Now join A, B, C, D, A, D, A. Then this is the overall projection of, development of the lateral surface of the pyramid. Same case if it is pentagon, hexagon, you have 4 segments here, pentagon 5, 6 for hexagon, 3 for triangle. That's all. Same procedure. Only thing is you have to catch this true length. If true length is not available, then find out. If true length is available, directly take it. Yes, for example, if I get this situation as initial position or the orientation, I will get directly like that. Pentagon, if the slant edge, one of the slant edge is parallel, definitely it comes with corner condition, naturally. Now, how to proceed? The development, this is overall development. I want only development of this portion, lower portion of the section plane. Okay. So here I got the true length. None of these lines are true lengths. I cannot take 1A and place it here and 2B and place it here. No, I have to project onto the true length. That's why we have identified the true length. This is the mistake many times people do. They never take true length and work. So directly they take it. These are important points for me. This is actually 11 dash 41 dash. Okay, just for true length I am taking one suffix. Here this is 21 dash 31 dash. Okay. Suppose that in this case you have section plane. Here only this particular line is not having true length. This and this are having true length. Directly you can take. Okay. Normally we project all the points on the true length, one of the true length line. Now, how to do it? Take always from apex. V11 mark here. V11 mark. Same length works for 4, that is on D, VD, same distance, and same distance for this one more A. So instead of keeping 3 A's independently, you can draw a thin arc completely covering entire overall development and mark those points. Okay, otherwise you can mark independently. This is 1, this is 4, this is 1. I got 3 points ready. Next, V2 and V3, not on the actual projection line. This is true length line only. You can take from V and mark. This is V2 and V3, same distance. This is 2 and 3. Now join them carefully and mark the respective development. Now join first profile. Any mistake I have done? Yes. This is 3 and this one is 2. Yes, this is 2. Now check twice before you start working for the overall projection. This is 2, 3 and this is 3 to 4. This one is 1 to 4. 1, 2, 3. 1 on VA, 2 on VB, 3 on VC, 4 on VD and 1 on again 1 EA. Now join this. Overall development is this. But what about 2B, 3C, 4D and all? Those must be in dark line. Okay. Now keep these lines dark. Yes. What about these lines? Let it be as such. You have made with 1, 3 in case of computer here 2H, very thin line. You retain the same because it shows the procedure. So this is how you draw the development of the pyramid in total, particularly square pyramid which is not possessing true length. I have identified the true length. In this type of cases you get directly true length. Now we will work out the same type of problem, little bit changes will be there on computer. Let us start with the square prism as the solid in the standard position. A square prism of 40 mm base edges and height 60 mm has its base on HP such that one of the base edges is parallel to VP or perpendicular to VP. For example, you know how to draw the projections. I will explain here only. See, the two sides parallel to VP, that is AB and CD are parallel to VP. Okay. Actually, these two represents in top view lateral surfaces or base edges, top edges, and these two are perpendicular. Fine. So you can either have parallel to VP or perpendicular, one and the same. It is cut by a section plane inclined at 45 degree to HP and bisecting the axis. Draw the development of the lateral face of the remaining portion. First of all, you have to draw the overall development. Now we will practice first how to draw the development in the computer. Okay. Now let me take up this only, this piece sheet only, and draw parallel lines. It may do leisurely so that there will not be any much problem. So always you have to fix the thin lines. First you check the thickness of the line. Otherwise you have to again come back and do it. Now this line again is baseline from the base projection 0.3. Yes. I am not extending XY. Actually, for purpose of developing, the XY stops here. Okay. So let me restrict that. Okay. Yes. Yeah. XY closes here. Then we will start working for the development. Now start with an edge AA1, that is the extreme left edge to the observer. Start from that visible edge line. Yeah, you can start with a line, thin line only again. Let's see how, yeah, thin line. Okay, now I have to repeat this 4 times because we have square. If it is pentagon 5 times, then 6 for hexagon, 3 for triangle. The same procedure. Now we have to catch this offset. So select offset. Before that, you have to select this. Say, now let me select this line and go for offset. Okay. Offset, he says, edit option. Yes. Offset. Yes. Now it is asking this one. He says select this. Then it will ask accept. And then only it will see how much distance you may need to maintain here. How much distance? I want 40 mm, base edges 40 mm. So enter 40. 40. Then see, it is asking which direction you continue offset, this direction or this. Yes, right side, forward. Yes. How many times? 4 times. That's all. Then say enter. Then left click. That gets you this 40. Now I don't want this dimensioning. It has automatically dimensioned. Then you select and remove that. Already I have shown that in initial stage. Still, see, and also you can remove this by trim. Yes. Now name this as A1, B1, C1, D1, A1. Again A, B, C, D, A. So likewise you can do this job. See, okay. See, I have done this job and then remove. This is overall development. A1, B1, C1, D1, A1 and also A, B, C, D, E. Project these lines. This is 2 and 3. 2 is on B and 3 is on C. Okay, next comes here 1 and 4. 1 on A and again here A. Before that you will get on D here. 4. Again on A. A1. Now name these points. This is 1 on A1. On B this is 2. On C this is 3. And this is 4. Again 1. Okay. Join them and get the corresponding pattern. Okay. So here is the procedure which I have followed. Now I came to explain how exactly you do this. Then join them and dark the overall boundary and also 2B1, 3C1 and 4D1 also. Don't forget. Okay, this is how you complete the problem on development required portion, remaining portion of the solid. Next, what I have done, whatever I explained in the previous session, in the explanation I have given to you in this session also. The section plane passing to the right top edge. Yes. Then you know how to draw the overall development. Then keep the points, intersection points, and these are the key points for you. 2 coinciding with B, 3 coinciding with C, because it is directly touching the top edge or top ends of the longer edges. Okay, now join this pattern. Okay, and also I stress this point, in between you get edges, remaining edges, actual edges you dark it along with the baseline. So this is how you can complete the development of the prisms. Now suppose that you have the section plane passing through a point on the axis 10 mm below the top end. You fix this as reference and then draw. Then keep the points of intersection properly. This is C. This is 1 on AA1. D 4 on DD1, but no way connected with the section plane BC, BB1 and CC1 like other previous two problems. Here the top edges A, B is having intersection with the section plane at 2 and 3 is with CD here. Just if I draw a line projecting downwards, projecting line, let me keep it thin line, yes, yeah. Now let me have this zoomed. See, this is 2 and this one is 3. Okay, it is intersecting the top edges which are parallel to VP. 2 with AB and CD, top edge CD is at 3. Now let me have the corresponding projection. See, as I said, 2 and 3 are key points. Point 2 is between top edge EAB and point 3 between top face edge CD. Now draw the development and complete the figure. How to complete the figure? See, here top edges no way connected with intersection, just like this problem. See, the extreme edge case. Extreme edge case I have. See 2 and 3 here. In no way it's connected, only top points are interfacing. Here it is different. The point is here, see 10 mm between AB from B. See 10 mm between AB from B. Here also 10 mm between CD from C, 10 mm. So you mark on the top face. AB is top face and CD is top face. Be careful in this type of case. These are key points for you. Okay. Now this way you can complete the typical problems on pyramids, prisms and pyramids. Now here the equally inclined to VP, base edges. This is one of the different case. The base edges are equally inclined to VP and the section plane is inclined at 30 degree to what? HP, and passing to the extreme right corner. Okay, here you get only corner, no edge business. Okay, now you know how to draw the development. Then you project, only single point is there on A to both sides, and then 2 and 4 on B and D. Then C is coinciding with top point of the longer edge. You will get the points like this, projected points 1, 2, 3, 4, 1 again. Then join those things. This is the pattern of development. Next, in the same situation, if the top face is intersecting, okay, now if the top face is intersecting with a particular angle of inclination, then what you do, this is no way connected to the intersection, C1 here, but top face intersecting. But in previous case, in front view as well as top view, it is true lengths. Just I will show you. In front view as well as top view, it is true lengths. Here, front view 10 mm, top view true. You can take either from front view or top view. But in this case, here it is different. See, this is parallel to XY, it is inclined to XY. So 3C and 4C are true lengths. In case of this, 4-C dash and 3-4 dash are apparent length. So you must take it from the top view. See, 3 and 4 are key points. Measure the distances 3C and 4C from the top view only to get the true lengths. That's what here. On these are all true lengths. You must take this into consideration very seriously. Make it. Suppose if you take it from this, it's wrong. Okay, because you get smaller dimension. You may not get the required shape or the required model. Okay, now you join those points. So this is how you get the solution. It's very simple. The only thing is you have to project directly from the front view and you have to measure from the top view wherever applicable. Wherever true lengths available, you must go there, catch it and then make it. Now suppose that sometimes you may get top face as well as base intersecting. Then what you do? Now I have the situation here. Top face also intersecting with section plane, base also intersecting. Only two longer edges are interacting with the section plane, two more are free from this section plane. So then what? Then you can project only 2 and 5. See, I have 6 intersection points. 1, 2, 3 are visible. 1 is on AB and 2 is on BB1 and 3 on CB, which is towards you. See, here if I draw a line, in case of section of solids we draw, otherwise here we don't draw. Okay, now if I draw a line, okay, now 3, 4 on top face edges, BC and CD. But if I draw the line here, this is going to represent the points on A1, B1 and D1, A1. See, D1, A1 you have 6 and A1, B1 you have 1. So like that you have to analyze. Now after getting all these points fixed and you have to complete the dark line, etc., whichever the portion is available, you have to draw arrows and all. Then you have to measure distances from the top view only. You cannot take distances from the front view, as I discussed in the previous problem. Okay, now you have to take distances from the top view and work out carefully. See, this is 15.51 on because it is symmetry, and here it is symmetrically. This line is going to make 2 halves, front view into 2 halves. So it is symmetrical. So definitely these are same values. So you have to maintain on base edges and top edges. Top edges CB and CD, base edges AB and okay, it is DA. Naturally, you have to take the distances and mark accordingly. Then you get final projection and the development like this. Now don't forget to dark the lines in between. Normally boundary will be dark all the cases, but majority of the time these three are missing, or at least one or two are missing. See that all the retained edges are to be darkened. Okay, so this is how you can work on the square prisms. If you work these problems, you can work any shapes, pentagon, hexagon, etc. Okay. Now I explained the rectangular prism also. Here the rectangular prism having 40, 20, 40, 20. Suppose that if I start from this point, okay. So this is from this to this, it is A to B is 40, yes. B to C is 20, and C to D is again 40. Alternately get. Sometimes what people do is take the all are 40, all are 20 and complete. Okay, you have to go through carefully, and this is longer and base, smaller base edges, you get the pattern like this. Same type of augmentation. It is inclination with HP, and these are the intersection points. Top corners are coinciding with the intersection points. Here 2 and 3 are key points, and 1, 4, 1 are on the respective longer edges. So these are all visible edges. Okay, this is about the prisms, square prism and rectangle. Now let me take the same thing on pyramid. We take up the one which I have discussed now. The square pyramid with 40 mm side and 60 mm height, section plane inclined at 45° THP bisecting the axis. Now from this point you draw section plane with the regular convention available, full line, hyphen, and that is third one used for axis. Now number of intersection points is 4 because it is not intersecting none other than slant edges. It's not intersecting base also. You may get that type of situation also. Here it is only the slant edges. One is intersecting with the VA and 2 is intersecting with VB, 3 for VC and 4 for VD. Now we can project and do it, but not necessary. Here we no business here. You have to find only true length. Okay, for that what I do is none of the lines are giving true length, either VA, VB, VC, VD. We want the slant edge true length. For that we are making this. This is actually section plane which I have shown in the beginning. And here how to do it? See, you make it parallel VB and project it and get B1 dash. This is B1 dash because this is moving locus B1 dash. Join VB1, that gets you true length measuring 66.33. Whatever is there, you cannot take. Computer can take, but there you approximately you take 66 manually, and you will get that type. Actually, it is the manual case. It's compass. Don't go for any scale. Directly measure compass and draw radial line. Okay. Now after this, as I said, you have to do this job. Now, how to create this? I will tell you. I will go for a new sheet and then work out better. How to create this? Now, let me take 66 mm radius line. Okay, this is center line, center point. Now I will draw this radius 66.33, whatever is available radius line, radial line. Okay, 66.33. Now draw initial line. Let me take it as VA. It is slant edge VA. Thin line only beginning. Yes, thin line. Now we are interested in 40 mm base length. This is slant edge length, true length, 40 mm base length. So you take 40 mm. Instead of going for arc, I will tell you one more method of fixing these points on the arc or line. Take directly line only. Okay, thin line, 40 40 mm. Now see that, this is the point. Now 40 mm, and move so that it touches the arc, gives you the point on the arc or point on the line. Click there, that's all. Then you join this. You will get one particular slant surface. Okay, that's all. Okay, so I repeat. Draw an arc. Otherwise, you draw true length of the slant edge 66.33. Then through with that reference, you draw arc. Then take 40 mm base length and see that it touches that. Otherwise, you draw an arc with 40 mm and then take join that it touches. Whichever is convenient to you, do it. Now, we have to create this type 4 segments. They have only one segment. How to do it? Now, you see that here I have mirror. Observe carefully. Mirror I have. Let me click on that mirror. He says, click on the elements to modify. Please press shift, etc. is there. Now, what I do is, I will select this first. Like this, you can select and go to this mirror. Okay, mirror. Then it will ask on what axis you have to mirror it. Yes, 1, 2, 3, 4, 5, or pentagons, hexagon, anything. Hexagonal pyramid. See, 1, 2, 3, 4, 5, 6, 7. Any number you can do. Whenever you want to stop it, you click for the sufficient number of them in the left click, and then finally you go for right click. That will stop. Suppose that you feel that one more extra, two more extra, don't worry. You try to undo. See, 1, 2, 3, 4, 5 I have. Just for demonstration I am doing this. Okay. Now this is how you create the segments radial line method in computer. It's very easy. Okay. So first you select. Otherwise you can do this also. I will show you. Instead of selecting the, don't name it actually. If you name those letters also will come along with this. It may duplicate many times. So you select, like, after doing this job, you select this. That's all. Now this will be selected. Then you go to this mirror. Yes. Then same thing. You fix the axis further. Yes. 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 Like that. Stop it. 1, 2, 3, 4, 5. Now I don't want one more. If it is pentagon, it will okay. Like then trim this. That's how you create this one. Okay. So it's very important. This is how we created. Okay. Now after this you join the baselines. See, A, B to B. Usually people forget to join this. Everything they do, they forget joining. But I don't want arc. I want these base edges to be marked. See again, how to mark this? As I told you, you take it on true length and measure individually V2 2, V2 3, V2 1, V2 4. So here 2 1 dash, V3 1 dash, like that. Okay. You accordingly you do it. On VA we have 1, on VB we have 2, on VC we have 3, and on VD we have 4, and otherwise what you can do is you draw 2 arcs. That is smaller dimension radius you draw between VB and VC, because that covers 2 radial lines. Then very big arc starting from this point to this point you draw with the major radius. That's all. Then you get, I have that type of the presentation also. You see, I have drawn this. This line covers 3 points, 1, 4, 1, and this. Then you can trim it. After you join, trim it. Okay, you please join and then trim it. No problem. These things you don't want. Trim these two. Otherwise, you independently you draw. Then join 1A, 2B, 3C, 4B, 1A, etc. Then also you see that all remaining edges are dark, base edges and part of the slant edges are dark. Okay, so this is how we get the solution. Again, the best thing is, if you draw in this pattern, you always start from A, unless otherwise it is specified. Like sometimes what happens, if you draw the section plane like this, if you start from this point you will get single development. Suppose that if you start from this, you will get two segments, two places you get development. Then in that case only you have to think twice. Otherwise, always start from this point. Okay. So this is what the development of square prisms and square pyramids. If you understand this very well, you can work out any problem in the uh, development of surfaces. It may be pentagon, hexagon, or whatever. In future, you will work pentagon, hexagon, cone, and cylinder type of problems.